this is Britt Caswell with another example video. In this video I'm covering example 1 from section 2-1, which is talking about transformations of a quadratic function. This comes from the Savvas Realize Algebra 2 textbook. So when I go to talk about transformations of a function, I actually use this little kind of formula to help me figure this out. Okay, this is the vertex form of a quadratic. And what it allows me to do is it allows me to describe the jobs of the a value, the h value, and the k value. Now, do you guys see how the a and the k are outside the grouping symbol? That means that whatever transformations these do, there's going to be some kind of vertical change. Alright, so anything that occurs outside of the value being squared is vertical. And what that means is that here this h, because it's inside the grouping symbol, is going to be a horizontal change. Then we look at what mathematical operations are happening. Here, where we are adding or subtracting things, those result in what are called translations. Okay, that is just a slide. So when I add or subtract inside the grouping symbol, it's a horizontal, which I just spelled horizontal wrong. Let's go ahead and fix that real quick. So when I do it inside of a grouping symbol, that is going to be a horizontal, there we go, translation. And if I add or subtract outside the grouping symbol, that's going to be a vertical translation. Now if I'm multiplying, multiplication or division is going to be a stretch or a compression. And the way that we tell whether we're stretching or compressing, at least when we're dealing with the vertical changes, is you have a stretch when your a value is bigger than 1, and you have a compression when the a value is a fraction between 0 and 1. Now the a also has another job. The a can also reflect. So if a is negative, you will have a vertical reflection as well. Alrighty. So then our translations have some directions they can go. So if our translation says minus h in here, you're going to go to the right. And if it says plus h, you're going to go to the left. And that feels a little bit backwards, doesn't it? Because the negative stuff's on the left. But just remember that h is the value being subtracted from x. So if I have, for example, x minus 3 squared, the value being subtracted from x is 3, and so I'm going to move to the right by 3. Okay, so that horizontal stuff, remember, feels a little bit backwards. Now here on the vertical side, there's a plus in the formula, so it's going to work in the same way that you would imagine it. So if it says plus k, this parabola is getting translated up, and if it says minus k, this graph is getting translated down. The only other thing that I want to give you a heads up that's specific to quadratics, I will do it in red, is talking about this a value. Remember, this a value tells you specifically how much the parabola goes up or down when you move one unit to the left or right. So say I have a parabola right here. Okay, here's my vertex. Okay, and this here is 1 unit left or 1 unit right. my A value tells me how far. Okay, I'm hoping this makes a little bit of sense here. Okay, so change this to purple. So again, here's my parabola. Here's my vertex. So when I go 1 unit to the side, the A tells me how far either up or down I have it. Okay, in this example, this is a negative A, right? It's a negative number because it's been reflected. But if my A is positive, when I go 1 unit to the side, it'll go up. Alright, so let's take a look at this in action. So I'm starting here with question A, and it has a -1/2 and a +2 inside there. So if I check out my little formula bar, I have an A. Okay, now that A is negative, so that negative there is a vertical reflection. Okay, that's what flips the graph upside down. The 1/2 that's being multiplied here is going to be either a stretch or a compression because it's multiplication. So I want to look, is 1/2 greater than 1, or is it between 0 and 1? Well, it's between 0 and 1, so that means that it's a compression. Alright, and then this +2 that's happening, this is inside the grouping symbol, which means that it's a horizontal change. It's addition or subtraction, which means that it's a translation. And what value is being subtracted from x? Okay, I could write this as x minus -2, if that helps you to see it. So it's going to go to the left by 2. So what I did was I graphed this out on Desmos. So let's see how these transformations look here on the graph. Alrighty, so if I start with my translation, you can see that it's gone to the left 2 from the origin. In terms of that reflection, the parabola is opening downwards. And the compression is always a little harder to see. But here, when I'm moving 1 unit to the side, do you see how it only goes 1 unit down? Now remember, that parabola, or that rule with the A, only works with 1 unit to the side. Okay, if I go an additional unit, it's not going to go down half, because the slope on a parabola is constantly increasing. So it only works with just the 1 unit to the side of this vertex. Let's try another one. Alright, so we have an A value, something being multiplied to the parentheses. It's positive, so it's not a reflection. It's outside the grouping symbol, so it's a vertical. Okay. It's multiplication again, so stretch or compression. And it's bigger than 1, which means that it's a stretch. So it's a vertical stretch with a scale factor of 2. This 1 is inside the grouping symbol, so it's horizontal. It's addition or subtraction, so it's a translation. And it says -1, so it's going to the right by 1. This -3, it's outside the grouping symbol, so it's vertical. It's addition or subtraction, so it's a translation or a slide. And -3 tells you it's going down by 3 units. So here's my graph. You can see that from the origin, it has gone down by 3. It has gone to the right by 1. And then if I check out that A value, so here's the vertex, here's 1 unit to the side. Do you see when I went 1 unit to the side, it went up by 1 unit, or up by 2 units? That's that vertical stretch. Let's try another one. So here we go. We have a negative being multiplied outside the parentheses. So that's a vertical change. A negative is a reflection. Now this is an imaginary 1, right? So 1 is neither a stretch or a compression because a scale factor of 1 just keeps it the same. So it's just a vertical reflection here. Now this 2 is inside the grouping symbols, so it's horizontal. It's addition or subtraction, so it's a translation. And when you have a plus 2 inside, it's going to the right, or sorry, to the left by 2, because it feels backwards from what it looks like. So if I take a look at my parabola here, my graph, you can see that from the origin it's gone to the left by 2, and then it reflected upside down. So the parabola is going upside down. So if I check my A value, right, and I go 1 unit to the side from the vertex, do you see how I only went 1 unit down? That's that imaginary 1 that you see right there. Alrighty, let's try one more, and I think that's the end of this example, yeah. Alright, so with this one more, there's no stretch or compression in front of it. So let's take a look at this minus 1. Alright, so it is inside the grouping symbol, so it's horizontal. It's addition or subtraction, so it's a translation. And then when it's subtraction, that's going to be going to the right by 1 unit. You see it here on the graph where it went 1 sideways. Now this plus 2 is outside the grouping symbol, so it's vertical. Alright, it's addition or subtraction, so it's a translation. And then it's addition, so that means that it is up. And you can see right here from the origin, it went 2 up. And there we have it. So there are some of our transformation rules applied specifically to a quadratic. Until next time.